the definition of moment of inertia. In that case, let this is a fixed axis and there is a particle at a distance r from the fixed axis, and mass of the object is m, and the object or body is rotating with a fixed angular velocity omega. Then its moment of inertia is defined as I equal to mass time square of the distance mr square. Now if it is not a point mass or it is a rigid body, then as we know, if we break a rigid body into small particles, then a rigid body will be summation of small masses. So after breaking, if we get different point mass from this rigid body, and let's say the mass of first point mass is m1, mass of second point mass is m2, mass of third point mass is m3, and mass of fourth point mass is m4, and so on, and at last the mass of nth point mass will be mn, and its corresponding distance is r1, and distance from the fixed axis to mass m2 is r2. Distance of fixed axis from fixed axis to mass m3 is r3. Distance of mass m4 from fixed axis is r4, and similarly distance of nth particle from its fixed axis is rn. Now, as we know, the moment of inertia of the first particle or first point mass is defined as I1. I1 means moment of inertia of the first particle will be equal to m1 r1 square. Moment of inertia of the second particle or second object is I2 will be m2 r2 square. Moment of inertia of third particle or third point mass will be m3 r3 square, and if we proceed in similar way, we will get the moment of inertia of nth particle will be in equal to mn rn square. Now if we add up or sum all these small moment of inertia of small particles, then if we sum this I equal to from 1 to n, as there is a n number of particles, equal to what? Summation of m ri square from I equal to 1 to n. But summation of all small inertia will becomes the total moment of inertia of the object. So total moment of inertia will become I equal to summation of m ri square from I equal to 1 to n. So this is the basic equation of moment of inertia for a system of particles. Now see what will happen if the object is not discrete. So, but this equation holds true for system of particles of discrete object. So this equation holds true for discrete object. Now if the object is not discrete or it is a continuous object, so for continuous object continuous object, continuous body or object, body, the summation symbol will be replaced by the integral symbol, In that case, the moment of inertia I becomes what? I becomes integration of dm r square, or it will be equal to integration of r square dm, where r square represents the distance from axis of rotation. R represent distance from axis of rotation, and dm represents the mass of a small element of the object, So basically, moment of inertia is defined as I equal to summation of m ri square from I equal to 1 to n, and this is also equal to integration of r square dm. So the first formula holds true for discrete objects, and this second formula holds true for continuous object. Now we will describe how to find the moment of inertia of different objects. So moment of inertia of different objects, for finding moment of inertia of different object, it basically depends on the distribution of mass. So moment of inertia broadly depends on the mass distribution. So what is mass distribution? So mass distribution is nothing but how mass is distributed for an object or body. So if you classify mass distribution, there will be three types of distribution of mass. So classification of mass distribution will be mass distribution can be classified into three categories. First one is linear mass distribution. For linear mass distribution will happen for a object, line type object, for a line object. or one dimensional object. So what is one dimensional object? Like example, a rod, a straight line, etc. And second mass distribution is area mass distribution. So for area mass distribution, will holds for an object which have a surface area. For an object which have surface area. For example, for a disc, a rectangular slab, rectangular plate, and a square plate, etc. And third distribution of mass will be volume mass distribution. So volume mass distribution will hold true for the object which have a definite volume. For an object which have a volume. For example, an sphere, and cube, etc. Now we'll calculate how to find the moment of inertia for different type of mass distribution. So first we will discuss about the moment of inertia about the linear mass distribution, that is for a straight line or a rod. To find the moment of inertia of a rod, so we'll